Right now, as you're watching this, something both extraordinary and deeply unsettling is unfolding within our solar system. An object, an emissary from the cold interstellar void named 3I divided by Atlas, is rocketing towards our sun at a staggering velocity of over 200,000 kilometers per hour. In precisely 9 days, on the 29th of October, it will hit perihelion, the most intense and violent moment of its entire voyage, a point of ultimate stress and speed. However, a chilling new calculation is causing sleepless nights for Harvard astrophysicist Avi Loeb. This interstellar traveler might not be just passing through. Fresh computations from his team indicate a theoretical possibility that it could harness the sun's immense gravity to execute a sophisticated braking maneuver, effectively anchoring itself within our cosmic neighborhood for good. Should this occur, Loeb cautions the repercussions could ripple far beyond the world of astronomy. We could see global financial markets plummet as humanity is forced to grapple with a reality-altering truth we have never before encountered: the permanent, undeniable presence of a technology far exceeding our own. But the story doesn't end there. It gets more disturbing. The latest data hints at something far more unsettling about the true nature of this object and its potential actions during the exact period it will be concealed from us, hidden by the sun's glare. This forces upon us a question of existential importance. Are we observing the random journey of a natural comet, or the meticulously planned arrival of a designed artifact? The mathematics behind its trajectory tells a tale that is becoming increasingly difficult for even the most resolute skeptics to ignore. When astronomers initially plotted the course of 3I divided by Atlas, they were struck by a statistical improbability. The object's path is aligned with our solar system's ecliptic plane, the flat, invisible disk on which all our planets orbit, to within a mere 5 degrees. To put that in perspective, an interstellar object should, by all rights, approach from any random direction in the sky. For it to arrive on a course so perfectly in sync with our planetary superhighway is akin to a blindfolded person throwing a dart from one continent to another and hitting the bullseye without any knowledge of the target's location. Yet, Avi Loeb has pinpointed something even more remarkable about this path, a distinct possibility that relies on a principle known as the Oberth effect. Understanding this single concept is key to grasping why the events of October 29th could pivot the entire course of human history. Picture a cosmic slingshot, but working in reverse. When a spacecraft plunges deep into a celestial body's gravitational field and ignites its engines at the lowest point, the moment of peak velocity, even a minor, efficient burst of thrust results in a massive alteration to its final trajectory and speed. The sun's gravitational well is the most profound and potent gravitational canyon in our entire solar system. And perihelion, that point of closest approach on October 29th, is the very bottom of that canyon. It's the exact instant 3I divided by Atlas will achieve its maximum speed of nearly 250,000 kilometers per hour. This compels us to ask, what if this object executes even a small, precise thrust at that critical moment? What if it leverages the sun's own gravity as a force multiplier to decelerate just enough to be captured by its gravitational pull? This one action would change its status from a fleeting visitor destined to fly by and vanish forever to a permanent, bound inhabitant of our solar system. The energy needed for such a maneuver is substantial, certainly, but not inconceivable. It's well within the realm of what we might anticipate from an object possibly equipped with its own sophisticated power source. And this is where the timing becomes either a matter of profound suspicion or another improbable coincidence piled upon an already unlikely scenario. On October 29th, 3I divided by Atlas will be positioned on the far side of the Sun from our viewpoint on Earth, placing it in a strategic blind spot. During this crucial interval, it will be completely invisible to us. Our ground-based telescopes will be rendered ineffective, blinded by the Sun's overpowering light. For several weeks, a gap will exist in our surveillance. And it is within this very gap in our observation that whatever is to happen will happen entirely shielded from our eyes. Now, we come to the core revelation, the new analysis that shifts this entire narrative from a fascinating astronomical occurrence to a truly disturbing enigma. Avi Loeb has just published his most recent findings on 3I divided by Atlas, and his conclusions defy everything we thought we knew about interstellar objects. His mathematical models, which are derived from the object's brightness, its gravitational effects, and its rotational behavior, suggest that this colossal traveler might not be solid. The data, as he puts it, increasingly and compellingly indicates something truly phenomenal. 3I divided by Atlas may in fact be hollow. Let me explain precisely why this single detail carries such immense weight. Initially, the assertion appears preposterous, a defiance of both common sense and scientific reasoning. Objects that have wandered between the stars for millions, if not billions, of years should be the epitome of solidness. We envision them as frozen, primordial mountains of ancient ice and compacted rock, born in the fiery gravitational forges of distant solar systems. They are expected to be dense, inert, and solid through and through. However, the mathematics, rooted in stark, objective observation, refuses to align with our comfortable preconceptions. From its observed luminosity and estimated dimensions, 3I divided by Atlas should have a mass of approximately 33 billion tons. To visualize this, picture stacking over 5,000 great pyramids of Giza to form one gigantic object. Its diameter is estimated to be between 5 and 46 kilometers, depending on assumptions about its surface composition. By any standard, this is a gargantuan object, and yet, this is where the deep paradox arises. When this object passed a mere 29 million kilometers from Mars on October 3rd, its gravitational pull on our nearby probes, its capacity to gently tug on them, was virtually undetectable. For all practical purposes, the spacecraft monitoring the event did not register its influence. For a seasoned astrophysicist, this is a contradiction as jarring as placing a dense, solid bowling ball next to a light, hollow basketball and finding that they exert the same near-zero gravitational force. The physics simply doesn't add up. Something fundamental in our direct observations is at odds with our most basic understanding of matter and gravity. This leaves us with just two possible explanations, neither of which fits neatly into our current scientific frameworks. The first possibility is that 3I divided by Atlas is composed of some unknown exotic material with a density far lower than anything produced by known natural processes, a substance even lighter than industrial foam insulation. This would force us to fundamentally rewrite our understanding of cosmic chemistry and material science. The second alternative is that there is significantly less physical matter within the object than its enormous exterior suggests. When the observational data is plugged into the equations, they consistently point to one explanation more strongly than any other. The interior is hollow. Loeb's argument is a model of elegant, logical deduction. If this object were a uniform, solid mass of compressed ice and rock, its total mass and its rotational dynamics would have to conform to a predictable set of mathematical relationships. They do not. The object's measured spin rate is too slow, too leisurely for a solid body of its apparent size. Alternatively, its gravitationally inferred mass is far too low to explain its observed rotational stability. According to Loeb, the only mathematically sound way to resolve these starkly conflicting observations is to remove a significant amount of mass from its interior volume. This creates a vast internal void, a massive cavity within. The unavoidable, though unsettling, conclusion is that of a shell structure, something that seems far more likely to be the product of engineering than natural formation. But it is at this point that the narrative takes an even more unsettling and speculative turn. If we entertain, for just a moment, the mathematical inference that 3I divided by ATLAS is a shell, we must then confront the next logical question. What function would such a hollow structure serve? Nature abhors a vacuum. Engineering, on the other hand, often embraces it. A hollow interior suggests a purpose. It suggests design. It suggests it is carrying something. This is where Avi Loeb's most recent hypothesis, shared in a recent blog post, transitions from the realm of the peculiar to the truly profound. He employs a carefully selected analogy that is both elegantly simple and carries a universe of chilling possibilities. Consider how a common dandelion disseminates its genetic material across a wide area. It doesn't depend on a single heavy seed that drops directly to the ground. Instead, it releases dozens, even hundreds, of smaller, lighter seeds. Each is furnished with its own miniature, elegant parachute. Each of these seeds is an independent agent capable of traveling great distances on gentle breezes, and each one can establish a new, self-sufficient colony if it lands in favorable conditions. Now, elevate that simple, elegant idea to interstellar scales. Substitute the biological drive for reproduction with a technological objective of exploration or observation. What if Loeb posits 3I divided by Atlas acts as a mothership, a carrier vessel transporting smaller, perhaps autonomous, probes within that immense hollow interior we've discussed? And what if perihelion, that moment of closest solar encounter, the instant of maximum velocity and stress, is the ideal pre-programmed moment for their deployment? This would represent a moment of supreme opportunity for the probes and, due to the observational blackout, a moment of minimal detection for us. What makes this speculative hypothesis so powerful and scientifically valuable is that it is testable. It offers a clear, falsifiable prediction that we can assess in the upcoming weeks and months. To date, despite intensive observation from our most powerful ground-based telescopes and multiple spacecraft, no smaller secondary objects have been clearly and definitively identified accompanying 3I divided by Atlas. Initial images from the European Space Agency's Mars orbiters did reveal some faint, hazy features near the primary object, but their own thorough analysis concluded that these are probably just data noise statistical anomalies in the detector readings rather than genuine physical entities. The current absence of accompanying objects is critically important because it establishes a clear before and after scenario for when the object reappears from behind the sun in December. If 3I divided by Atlas is merely a large, natural comet undergoing extreme thermal stress as it heats up, it might very well break apart into smaller fragments. If this occurs, we would expect to see these fragments passively separating, following slightly varied trajectories determined solely by the momentum from the initial breakup. They would create a dispersing cloud of debris. However, if it is a designed object, a carrier vessel deploying probes, the pattern of separation would be fundamentally different. We would not anticipate seeing a random cloud of debris slowly drifting apart. Instead, we might witness discrete individual units moving with seeming purpose. we could potentially observe them accelerating away from the main body, not just passively drifting, and most revealingly, they might be directed toward specific strategic destinations within our solar system, perhaps towards Earth, Mars, or the asteroid belt. The dandelion seed hypothesis provides a distinct, observable signature that differentiates it from a simple natural fragmentation event. This dandelion seed hypothesis, as speculative as it may seem, has tangible consequences for the scientific community. The Galileo Project observatories, under Professor Loeb's direction, are not solely focused on distant stars. They represent a new class of instruments specifically engineered to systematically and rigorously scan Earth's atmosphere for unidentified aerial phenomena, or UAPs. Loeb has explicitly stated in his writings that any new anomalous activity detected in our skies that coincides with the perihelion passage of 3 I divided by Atlas would be of the utmost and immediate scientific concern. The search is a dual effort. We are not only observing the object itself, but we are also now scrutinizing our own atmospheric doorstep for any potential visitors it might have dispatched. If objects suddenly begin to materialize in our skies, if our global sensor networks register anomalous readings that cannot be explained by conventional aircraft, satellites, or natural atmospheric phenomena, the temporal link to 3I divided by Atlas's perihelion event would be too significant to be brushed aside as mere coincidence. The experiment is underway, and now we come to what is perhaps the most bizarre and immediate aspect of this whole affair, an event that has already transpired. After 3I divided by Atlas made its closest approach to Mars on October 3rd, passing within a mere 29 million kilometers of the red planet, something entirely unforeseen occurred. The data stream went silent. A coordinated global blackout of information descended upon the event. NASA's Mars Reconnaissance Orbiter, with its legendary HIRIS camera, a telescopic instrument so powerful it can resolve features on the Martian surface the size of a dinner plate, was perfectly positioned to capture the most detailed images ever taken of an interstellar object. The European Space Agency's Mars Express and Trace Gas Orbiter also had clear, unobstructed views. And China's Tianwen-1 mission, a sophisticated orbiter equipped with its own high-resolution imaging systems, was also in the vicinity. Yet, the comprehensive, high-resolution data from these key missions has been conspicuously, deafeningly absent. NASA has cited the unfortunate timing of a government shutdown that commenced just 48 hours before the flyby, a bureaucratic gridlock that they assert froze their public communication channels at the exact moment this historic observation took place. The European Space Agency, even weeks later, insists that their data is still tied up in complex processing pipelines awaiting analysis. And China, whose space program typically celebrates its successes by sharing images within days, has remained officially silent. The ESA did release a few preliminary low-resolution images that showed some faint, ambiguous features around 3I divided by Atlas. However, their own official analysis suggests these could simply be noise artifacts, random statistical fluctuations in the detector readings, rather than genuine physical structures. It was a release that appeared to reveal nothing, a trail of breadcrumbs leading nowhere. The timing of this global information blackout continues to provoke profound questions. When multiple competing nations simultaneously delay or withhold data from such a globally significant and eagerly awaited event, it warrants our full attention. It implies that the data is either profoundly underwhelming or profoundly unsettling. And given the object's existing portfolio of anomalies, the latter seems an increasingly plausible scenario. So here we stand on the edge of a precipice of immense uncertainty, looking into a week that could potentially reshape the human story. The evidence before us weaves a chilling tale. We are monitoring a colossal, impossibly massive object that moves with the inertia of a small moon. Its trajectory is so statistically unlikely that it pushes the boundaries of coincidence, aligning perfectly with the path an intelligent probe might choose to survey our solar system. The very material it sheds reflects light in a manner foreign to our galactic neighborhood, and its chemical signature suggests an origin on a planetary surface, not in the cold vacuum of space. Most disturbingly, the mathematics strongly suggests that this object may be a hollow shell. And this shell, this potential mothership, is now just days away from a critical maneuver, a final play at the moment of its closest encounter with our sun, which will happen precisely when our ability to see it is completely obscured. We will learn the truth, or at least its next chapter, within a matter of weeks. On October 29th, as 3I divided by Atlas emerges from its journey behind the sun, the universe will provide an answer to a question humanity has pondered since our ancestors first gazed at the stars with a mixture of wonder and fear. Is it just another peculiar but ultimately natural comet that will continue on its course and disappear forever? Is it a derelict, ancient alien artifact, a hollow ghost ship that has been drifting aimlessly for eons? Or is it something active, something intelligent, something that has just made a deliberate choice about its future in our solar system right under our noses while we were blind to it? What do you believe is truly happening here? As we find ourselves in this brief, suspenseful interval before the events of October 29th play out, the global discussion is taking place right now. Are the documented anomalies simply a series of incredible coincidences, a demonstration of the universe's infinite capacity for strangeness, or do they form a coherent pattern, a body of evidence pointing to a conclusion too profound to readily accept? Share your thoughts and theories in the comments below, and subscribe to stay informed as this story unfolds. Because the next revelation, the next piece of this puzzle, might be closer than any of us imagine. The truth is on its way. The only question is, are we ready for it?